this is module 25, use isosceles and equilateral triangles. We have to go into a little bit more depth on what an isosceles triangle is. If you remember the definition, at least two sides of the triangle are congruent. The one that is not part of the congruent sides, we call that the base. It's also the third side of the triangle. What the base creates with the two congruent sides is something called base angles. And those are the two angles adjacent to the base. So these guys here would be called base angles. Here. Isosceles triangles has exactly two congruent sides, and we call those sides legs. And the vertex, we're going to call the angle that is created when the two legs come together, the two congruent parts of the isosceles triangle. So that's called your vertex. You have your base angles, and you have your legs. The reason this is important is because we have a theorem that's called the base angles theorem, and it states that if two sides of a triangle are congruent, then the angles opposite them are going to be congruent as well. So remember the labeling dash marks. We have two sides, one here, that are congruent, and if we know that those two sides are congruent, we can automatically conclude that the base angles are also going to be congruent as well. The converse of this, if you remember the converse, you flip the hypothesis and the conclusion, but the converse of this it states that if you have two angles of a triangle that are congruent, then the sides opposite them are going to be congruent. So the exact converse is going to be true. So if we know the base angles are congruent first, we can conclude that the sides opposite those base angles are going to be congruent. Another thing I want to touch upon is something that we went through in a previous module. That's the hypotenuse leg congruence theorem. One of the things that is evident that we have so far to prove triangle congruence, we have side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse leg. The thing we haven't talked about is ASS, or angle, side, side. And yes, I know it looks funny, but one of the reasons why people remember it is because angle, side, side. This is a particular part. It's the only time when side, side, angle, or angle, side, side does not, or does actually work. Because any other time, you could still have a congruent side, another congruent side, and an angle. Here is an example. For example, if we have an angle here, this angle here is congruent, this side here is congruent, and this side here to another triangle, well, I can draw almost an identical triangle using the exact same angle measurements of one part. This side still stays the same, this side still stays the same, but as you can see, this angle here and this angle here have changed. So angle side side does not work except in the special case of a hypotenuse leg. So that's why we say it's a special case and we call it hypotenuse leg. So we know that in a right triangle, that's why hypotenuse leg. If we have the hypotenuse and a leg of a right triangle are congruent to the hypotenuse leg of a second right triangle, then we can show that the two triangles are going to be congruent. So, and this works for if you know one leg, and it doesn't matter which leg, it could be this leg or it could be the opposite leg as well. So, copy and complete each statement. This is pertaining to the base angles theorem. So if I see that HG is congruent to HK, what two angles are going to be congruent? Well, in this figure, I label HG, I label HK. Since I know that these two sides are congruent, that means I can conclude that this angle is congruent to this angle because of the base angles theorem. So, solution is HGK is going to be congruent to angle HKG, and that's by the base angles theorem. What if I did the converse? So I give you first that KHJ, which is this angle here, and KJH, which is this angle here, are going to be congruent. So I labeled them as congruent. If I know that the angles are congruent first, then I can conclude that the opposite sides are going to be congruent. If you want to draw arrows to kind of help you out, fine by me. But again, solution is KH is going to be congruent to KJ because of the converse of the base angles theorem. Okay, so we have a couple corollaries that we have to talk about. Remember, corollary is something that is easily proved by using the actual theorem. So we have a corollary to the base angles theorem. If a triangle is equilateral, then it's equiangular. The thing is, and the converse is also true, corollary to the converse, if a triangle is equiangular, then it's equilateral. Well, we know that the triangle's angle measurements add up to 180 degrees. The thing that we have is we have three sides, or three angles. In an equilateral triangle, the angles have to be congruent as well. Well, if you use the base angles theorem a couple times, you can say that this is congruent to this is congruent to this. We also know that this is congruent to this. So it basically shows that if you're equiangular, you're also equilateral. Equal angles means equal sides. And the converse, again, if it's equal angles are shown, then you can say that it's equilateral or equal sides. So, and those are kind of intuitive theorems, but again, just to kind of go over equilateral versus equiangular. And if you remember, this is back in another module, but we have something is called a polygon is a regular polygon if it's both equilateral and equiangular. But that's going to be also talked about in a later module as well, more in depth, what regular means. So, okay, so I'm giving you an equilateral because it's labeled, each one of the sides is labeled congruent. It asks to find the measures of angle P, angle Q, and angle R. So there are a bunch of different ways of doing this, but if you notice all the sides are congruent, you can also say that all the angles, I can call this X, I can call this X, I can call this X. And if I add all three of these X's together, so add 3X, that's going to equal 180 degrees, because that's what the triangle sum theorem states. Divide by 3, that means each one of these angles will measure 60 degrees. So equiangular and equilateral are always going to measure 60 degrees at the angles. Okay, in this one it says find ST in the triangle at the right. So what is labeled is you have angle S is congruent to angle T, which is congruent to angle U. Since all three of them are labeled congruent, we can automatically conclude that all the sides are going to be congruent. So if TU is 5, we know UT is going to be 5, we know ST is going to be 5. So it says find ST, so ST is going to be 5. And again, because it's equilateral, then it's going to be equiangular. So we use, again, the base angles theorem a few times, and we can show that.